Let's analyze together a specific logarithmic function and find all the components that will help us to graph it. The function f of x that we have is the log with base 3 of x plus 3 minus 2. There are many different ways to approach the graphing and analyzing of this function. There are a few things that are very important to remember. One of those things is that logarithmic functions have a specific shape. Now, what do we know about logarithmic functions? When you have a logarithmic function that it doesn't include any minus either in front of the function or inside the argument in front of the variable x, then the shape of the logarithmic function is this. This is always true, and the logarithmic functions always have some vertical asymptote. So, if we know how to approximate the graph of the function that we expect, we have already started analyzing the function. The next thing that we need to know is what is the vertical asymptote. So let's work on some of the details. State the domain and the range of f. What we need to remember. One of the things that you can remember is that the range of a logarithmic function is always from negative infinity to positive infinity. This is true for all logarithmic functions. Remember, the range of a logarithmic function is the domain of the corresponding exponential function. And exponential functions have domains that start from negative infinity to positive infinity. So that was easy to calculate. The next thing that we want to find is what is the domain of this function. Well, the domain of logarithmic functions can and may be limited. They are always limited, actually. They are limited, and the limitations that we have for the domain, the way that we limit the domain, depends on two things. The shape of the logarithmic function that we expect, and also the vertical asymptote of the logarithmic function. So it would be wise to first find what is the vertical asymptote. How do we find the vertical asymptote of a function, of a logarithmic function? What we need to do is to consider the argument of the logarithm, which in this case is x plus 3, whatever is inside the parenthesis, set it equal to 0, and find the solution for this equation. X equals to negative 3. This is going to be the vertical asymptote for this logarithm. So the vertical asymptote that we expect for this logarithmic function is going to be x equals to negative 3. Okay, so we know the shape because there are no minuses, and we also know the vertical asymptote. What about the horizontal asymptote? Well, logarithmic functions have no horizontal asymptotes. So this is an answer that holds for all logarithmic functions. Range is from negative infinity to plus infinity, no horizontal asymptotes. The vertical asymptotes, we find them if we set the argument of the logarithm and we find the solution for that. If we have now the vertical asymptote to be x equals to negative 3 and the logarithmic function to be increasing to the right, then this means that the graph of the logarithmic function will decrease towards the negative infinity here and will increase all the way, but slowly, to positive infinity here. So this means that if you see where the specific curve shatters the x-axis, it will stop right here. So all the points from negative 3, not including negative 3, to positive infinity will be in the domain of the function. So this means that the domain of the function is from negative 3 to positive infinity. Remember that we do not include the negative 3 in our domain. Why? Because if the x is -3, then the argument will be 0, and there is no logarithm for 0. It cannot be defined. Okay, so we answered the A and the B. Let's go to the C. We need to find now the x and the y intercepts. How do we do that? Well, let's start from the y-intercept that we all know that to find that we need to set the x equals to 0. So we need to find the f of 0. This is going to be equal to the log with base 3 of 0 plus 3 minus 2. Now, inside the logarithm, I have 0 plus 3, that is nothing else than 3. Now, log of 3 with base 3 is 1. So I have 1 minus 2, that is equal to -1. So this means that the y-intercept will be the 0, -1 point. If I want, I can also graph it right here. So I know, for my graph, I know few things already. I know the y-intercept, that is right there, and I also know the vertical asymptote that passes through the -3. Now I want to find the x-intercept. The x-intercept is going to be slightly more complicated. Why? Because now I need to set the function. Which function? The function that I have right here, f of x equals to 0. And then I want to find what is the x in this case. F of x should be equal to 0. But what does this mean? This means that log with base 3 of x plus 3 minus 2 is going to be equal to 0. Okay, so I set up right here a logarithmic equation, which I need to solve. How do I solve logarithmic equations? First of all, I need to isolate the logarithm on the one side of the equation. So I'm going to pass the -2 to the other side of the equation. And I do that by adding +2 on both sides. +2 here and +2 here. This will cancel the -2 with a +2, and I will end up having log with base 3 of x plus 3 equals to 2. Now, I have an equation where the one side has a log and the other side is a number. How do I solve this equation? Well, the way to solve this equation is one. I need to get rid of the log of 3. And in order to do that, I need to raise both sides of the equation, and I need to use as the base of the logarithm. So I'm going to rewrite now this as 3 to the log with base 3 of x plus 3, and this is what I will have on the left side, and on the other side I will have 3 to the second, because 2 is the number that I have here as my constant. So 3, because this is the base, to the second, 3 to that. But remember, again, right here, that I can use the properties of logarithms, and the properties of logarithms tell me that if I have a log with base a of a to the k, this is nothing else than just k. And this is the case right here. And I also, if I have a to the log with base a of k, this is also equals to k. I'm going to use the first property right here, because this is what I have. 3 to the log of 3, a to the log of a. So I can cancel the 3 to the log of 3, and the result that I will get will be x plus 3. So x plus 3 is equal to 3 squared, that is 9. So this gives me x equals to 9 minus 3, that is equal to 6. And this means that the x-intercept will be the intercept 6, 0. Now, I can add this to my graph, and this will be the point 6, 0 right here. So I have 2 points and I have my vertical asymptote. So this means that I can graph my equation. My function. And my function will look like this. This will cross the x-axis at the 6 plus 0, 6, 0, and the function will look like this. As you can see, if you compare with what you were expecting at the beginning, the function does look like that. Okay, now what else do I need to do? Well, what I want to do is to find the inverse function for my initial f of x. In order to do that, what we want to follow are the steps for finding the inverse of a function. So the first step is to change the f of x with y. So I have now y is equal to log with base 3 of x plus 3 minus 2. Remember, that's the first step. Change f of x, replace f of x with y. What's the second step? Interchange the y with the x. So these need to change places. And I have now x equals to log with base 3 of y. I change the x with the y and the y with x, plus 3 minus 2. The third step is that I want to isolate the y. And in order to do that, I have to take several steps. The first step that I have to take is get rid of the negative 2 from here. How do I do that? Well, I can add 2 to both sides of the equation in order to maintain the equality. Minus 2 plus 2 is equal to 0. So what you can see right here is that I have x plus 2 on the left side, and on the right side I have log with base 3 of y plus 3. Unfortunately, the y is inside the argument of the logarithm. And since I want to solve for y, I need to get rid of the logarithm. How do I get rid of the logarithm? This is the fourth step. So I am going to create a different type of equation, the equation that I have right here. I will use that since x plus 2 is equal to the log with base 3 of y plus 3. Then I will take the base of the logarithm. I will write this to both sides of the equation, and I will raise the 3 to exponent x plus 2 right here, and exponent log with base 3 of y plus 3 on the right side. Why am I allowed to do that? I am allowed to do that because x plus 2 is equal to log with base 3. And since I use the same basis, then these two quantities will be equal as well. Okay, now the left side of the equation is an exponential expression now, 3 to the x plus 2. Now the right side of the equation, I can use the property that tells me that a to the log of a of any number k is equal to k. So basically what this function tells me is that whenever I have this situation, I can simplify the a with the log of a, and what remains is k. So I do that because right here I have 3 and log of 3, and this is equal to y plus 3. So in this way, I brought the y from the exponent and inside the log to the main equation without log. So the fifth step is again to isolate the y. Remember, in order to do that, I need to leave the y alone on the right side. And in order to do that, I can subtract, in this case, the 3 from both sides of the equation. So what I have is 3 to the x plus 2 minus 3 here equals to y, because 3 minus 3 is equal to 0. Okay. And the sixth step is to change the y and rewrite it as the inverse of f. And this is going to be the inverse of the function, is equal to 3 to the x plus 2 minus 3. And that's my function. This is what I wanted to find, the inverse of the initial f of x function. And this is an exponential function. Since the initial one was a logarithmic function, I expect that the inverse will be an exponential function. So going back now to our graph, and this is the graph of the initial function that I had, the f of x. I may want to now graph the inverse of this function on the same graph. To do that is simple. First of all, I'm going to consider the 2 points that I already have, the 0, -1 and the 6, 0, in order to exchange the x and the y and find 2 points of the inverse function. Since the 6, 0 is a point of the initial function, then this means that 0, 6, that is the point right here, is going to be a point of the inverse. Since -1 is 0, -1 is a point of this function, then this means that 0, -1 will be a point of the inverse. And since x equals -3 is a vertical asymptote of the initial function, then this means that the line y equals to -3 will be a horizontal asymptote for the inverse function. So this means that my exponential function should look like a function that asymptotically moves towards the line y equals to -3, crosses the curve, crosses the x-axis at -1, 0, crosses the y-axis at 0, 6, and increases very fast to the infinity. If you compare these two functions, the purple and the blue, you will easily see that these two functions are symmetric around the line y equals to x. That, as we know, is the case for any two inverse functions. Now, if you want to see the same type of graph in a better, more precise presentation, we can see it at Desmos. The logarithmic function is already graphed right here, and we can see the blue line that is the vertical asymptote for that function. What we can do is we can add to our graph the function x plus 3 minus 3 and we can see the 2 points right here, the y-intercept, the x-intercept for that function, and the y-intercept, 0, 6, that are points that are they have interchanged coordinates. We can also see that the line y equals to -3, the red line right here is a y, it is a horizontal asymptote for the black curve, that is the exponential function, the inverse function that we have. And if you want, you can also graph the line y equals to x to see the symmetry between the two curves, especially as they move and they extend to the infinity.